Respected Professor, we are from the team Text Creators. My name is Kamurthy Raviteja and my teammates are Balaji Nateshan, Ganesh Shankar Putta, Kalej Chakradhar. And my project is text generation using recurrent neural networks. Let's see the contents, what are inside. We are going to deal with introduction part. Inside, I am going to discuss about RNN, the language model, and then the methodology, experiment, and finally we will end up with results, discussion, and conclusion. Next slide. Yeah, here we will discuss about what is recurrent neural network. It's a type of neural network that contains loops, allowing information to be stored within the network. In short, recurrent neural network uses the past data to predict the future behavior. The best example is stock trades and web logs, sensor logs. Even the self-driving car also comes under this category, RNN. These quoted examples comes under time series information or data. If you want to talk about sequential data, the best examples are image captions, machine translation, machine generated music. RNN deals with wide number of possibilities. We have four combinations in RNN topology. The first is sequence to sequence, second sequence to vector, then vector to sequence, and then sequence to vector, and then to sequence. The above quoted examples best suited under these four combinations only. If you look about the figure here, the individual neurons have inputs and then the outputs are again connected, means back. The feedback is coming back. Here, crisply saying that the output, the future output is depending upon the past output. Next slide, please. There is a glitch here in RNN. Actually, the straight from earlier time steps or information might dilute over a course of time. The best possible solution to tackle this is using a LSTM cell. That's a short-term memory cell. It maintains some memory or like storage for to hold the information. Then let's talk about what's the language model. It is a use of various statistical and probabilistic techniques to determine the probability of a given sequence of words occurring in a sentence. Language models analyze bodies of text data to provide a basis for their words prediction. According to the natural language processing NLP, they says it's a neural network trained to predict the next word in the sequence. In the project, we are going to deal with text generation. The most important thing in text generation is to decide what is the informational unit which is going to predict. Some predictions of a word requires a neural network to understand the order of the previous ones. Most of the LMS have architecture based on either some of the recurrent neural network. The most important application of language models is to be used as a pre-trained model to fine-tune for another use like sentiment analysis or text classification. Next slide, please. From here onwards, my friends will take the lead. Balaji, now you can go ahead.
Hi, and my topic is about to discuss about the methodology. So, what we did in this project is we used 5 modules like RNN units and Glarot AK Xavier installer also for us, Adam optimizer and LSTM unit and SGD optimizer. So what we did this in this project is we created our own data set to train our model. So we train the model to create a best output. Like as we said, this is a text generation. So what the text generation will generate is all about paragraph, a poem, or any article if you were searching for. What we provided in the data set is all about we put an input of paragraph like country or country's history or countries what are the best thing in that, and also we add some poems like uh, uh, sorry, just cut this part, okay. Let me talk from the poem thing, okay. Shekwara. Who that? Who was that? Shakespeare, right? Okay, okay. We add some Shakespeare's poem and also some articles from online. So we created our own data set to train our model. We train all the model to its best, and we compare the result with others. So the real work of this project is to generate a paragraph or article which is related to your question. For instance, if we give a word of India, it will produce the best thing of India, like a history. In case if you want poem, just you just need to give the what poem do you need? Just Shakespeare's. It will produce some best poem for you of that part. And the experiment what we did this in this project is the goal of our experiment is to demonstrate the RNN which trained for 2 hours to produce the high quality language model. So we demonstrate this by comparing with RNN to sequential memorizer. So also owing to it non-parameter nature, and the nature of the data structure it use the sequence memorizer is very memory intensive. Also, so it can uh, only apply to the training data set of roughly, like it will come around 130 MB, around MB, on a machine with a 32 GB of RAM. So we just need a high efficient machine for this thing. Um, Here is the result and the discussion part. It will be the discuss by our. Just cut this part also. Mm, let me finish this. That's what. After that, Chakri, talk about this thing, bro.
Yes.
Do I need to mention your name?
No need, no need, bro.
Okay, just cut from where I left. Sorry,
Yeah, it's okay, bro. Now coming to the results and discussion part. In this project, we have added all the required possible variable probabilities to the RNN model, and in this we have achieved an accuracy of 89% after giving the 10 epochs, and we have we have achieved the loss function as 0.992, and also with the help of the word embeddings and the deep learning models like RNNs, CNNs, VAEs, and GANs have made the natural language processing problems a bit easier, and we have predicted and also generated the correct characters by giving an essay like which is having some errors in the word phrases and also the sentences, and after training the model we get the output which is having the all corrected word phrases and also the sentences. I'll show in the next slide, and here we can see the essay which came as an output after training the model by removing all the errors. And here we can see the 10 epochs which we had an loss function of 0.992. And next, my friend Chetty will discuss about the conclusion.
This is
This is Chakradhar. Now I explain about this project conclusion. The deep learning provide has a way to strap hug amount of computation and data with a small effect done by hand with the help of word embedding and popular models of deep learning like RNN and generative has made NLP problems a lot easier. The generating natural language is a chalice of text generation, research, and technicalities and interpretation of natural language, which aggregates when generating longer text. The final this conclude with this statement that the area of continuous data is dominated by the generator while the discrete data is dominated by variational autoencoders. And next, right, future works. Here, here future works. We thus introduce the recently proposed methods for text generation based on reinforcement learning and reparameterization tricks and generative adversarial network techniques. Uh, we compare different properties of those models and the corresponding techniques to handle their common problem such as gradient finishing and generation diversity. We start from recurrent neural network language models with the traditional maximum likelihood estimation training scheme and the point out its shortcoming for text generation. We expect to see more NLP application to employ reinforcement learning methods to explore the research on text generation. Thank you.
Let's end up from here. Okay.